Hi, I'm Wei Lien Dang, co-founder and chief strategy officer at StackRox. In this video, I'm going to give you an overview of Kubernetes security, covering how to approach it and some key takeaways that you can keep in mind as you look to protect your containerized applications. Kubernetes is a powerful, robust system for container orchestration, but it's also a complex one with multiple components that must be secured. Let's start by categorizing and walking through those components and how they fit into infrastructure and applications. Along the way, I'll talk about various security boundaries that enable different types of isolation, which you can incorporate into your overall approach for securing Kubernetes. Your Kubernetes environment may have one or multiple clusters up and running. Today, we're going to focus at the level of an individual cluster. Now, a cluster serves as a sort of security boundary that you can use to segregate your applications across your environment. And you can do so in a flexible way. For instance, you might have a cluster that runs dev test workloads, or you might have one that serves a production environment. Alternatively, you could have a single cluster that runs many different applications at the same time. A Kubernetes cluster can be thought of as consisting of two main sets of components, as well as a set of controls that are applied across those components. The first part of a cluster that must be secured is called the Kubernetes control plane. The control plane is a set of components that makes global decisions for managing a cluster's operations. The second part of the cluster that must be secured is made up of the individual nodes that make up the cluster. And when it comes to security, there are the set of security controls that are natively available in Kubernetes that can be applied across these components at multiple levels throughout a cluster. Now let's get into the individual components that make up each of these key parts of a cluster. And we'll start with the control plane. One of the most critical components within the control plane is called the API server. The API server is responsible for managing all API requests and also serves as the main interface for cluster communications. Next, there's etcd. etcd is a data store that Kubernetes uses to store all cluster data. Then there's a component called kubescheduler. This component is responsible for managing pod scheduling based on resource availability, requests such as taints and tolerations, as well as other policy criteria. There's also a component called kubecontroller manager. This component is responsible for regulating the state of objects throughout a given cluster. And then finally, in cloud environments, there's an additional component called the Cloud Controller Manager. This component is responsible for managing cluster dependencies for functions such as load balancing and node termination. Because the control plane makes global decisions for a cluster's operations, securing a cluster requires protecting the control plane as its first step. Some key considerations and best practices to secure the control plane are as follows. First, upgrade to newer versions of Kubernetes to avoid vulnerabilities in the Kubernetes API server as well as other components. Next, set up authentication for all Kubernetes API clients. And then, configure authorization and set permissions on who can do what via Kubernetes Role-Based Access Control, or RBAC. Next, ensure that all API traffic is TLS encrypted. And also turn on audit logging to ensure that API events are recorded. And finally, set up strong authentication and restrict access to etcd itself. Now that we've covered the infrastructure components that make up the control plane, let's turn to those that make up the individual nodes within your cluster. Now, nodes can also be viewed as providing a valuable physical boundary to segregate applications throughout your cluster. Worker nodes run your containerized applications, and they also consist of a couple key components. The first component is called the kubelet. The kubelet is the primary node agent that's used to manage individual containers on a given node. The next component is called kubeproxy. Kubeproxy is used to handle request forwarding based on network rules and various network protocols. The third component is the container runtime. This provides the functionality needed to manage and run containers on a given node. Some steps to protect the following components include the following. First, set up authentication and authorization on the kubelet, because, for example, by default, access is unauthenticated. Next, make sure that you're following best practices to secure and harden the container runtime, adhering to standards set out by organizations such as the Center for Internet Security. Now that we've covered the primary infrastructure components that make up both the control plane and the nodes within your cluster, let's turn to the application components that are running throughout your cluster. And to do so, we can start with a concept called namespaces. Namespaces provide virtual boundaries that can be used and applied to effectively run multiple virtual clusters within a single physical cluster. Namespaces can be used to isolate applications, projects, teams, or users, and they can also be used to divide up cluster resources. Some things to keep in mind when you're configuring namespaces are that they can be used to, first, scope applications. For example, you could assign a single application to a single namespace. Second, you could also restrict access by granting different permissions to different users on different namespaces. Now, within each namespace, one or more workloads will run. And these workloads, which consist of your application components, can be created and managed by what are known in Kubernetes as controllers. And these controllers can be of different types, including deployments, stateful sets, daemon sets, and so on. And from a security perspective, why they're so valuable is that they allow you to do a few different things. They allow you to first declaratively configure their intended state, meaning you can specify aspects of security via a manifest or configuration file or artifact, some other artifact that pertains to a given workload. You can also use metadata from controllers to gain more context and insight that can be used as part of security decisions. And then third, you can automate security configurations by specifying criteria for the workload resources that these controllers manage. That then takes us to the lowest level of individual compute within a Kubernetes cluster, which are pods. Pods are the smallest unit that can be created and managed within Kubernetes, and they consist of one or more tightly coupled application containers. Pods in a cluster can be hardened and secured using multiple different approaches. For example, I'll provide two. First, security context can be used to configure and restrict what pods can do. For instance, you may want to restrict a pod from running privileged, or you may want to configure the container's root file system to be read-only. Second, you can also enforce policies on conditions that pods must meet in order to run within a cluster. Now that we've covered the components that make up infrastructure and applications running throughout a cluster, let's turn to the native security controls that can be applied across these components within a given cluster. And one of the great things about Kubernetes is that it makes available a number of different native security controls that can be applied at different levels to different resources in a cluster. One of the controls that it makes available is called role-based access control. Role-based access control can be used to authorize permissions on both application components, resources, and users that are operating within a cluster. Another control that Kubernetes makes available is network policies. These can be used to segment and restrict pod-to-pod traffic and limit the blast radius of any potential attack within your environment. A third capability that Kubernetes makes available is secrets. And this enables you to both store and manage sensitive data such as credentials that might be used by your containerized applications. Finally, another capability that Kubernetes makes available is called pod security policies. And these can be used to restrict and enforce criteria that your pods must meet in order to run within a cluster. Kubernetes is transforming the way organizations build, ship, and run modern applications. And while there's a lot to think about or to take into consideration when securing Kubernetes, it's helpful to think through the infrastructure and application components, as well as the native controls that can be applied across those components, as a useful framework to help you implement and achieve comprehensive security. To learn more about Kubernetes security and the StackRox platform, please visit www.stackrocks.com.